Hi guys, it's Mr. Frederick here. Welcome back to Stats. We're with period 4. We're talking about randomness and probability. All right. So, just as we've done in the past, there should be on each slide maybe a formula or a statement that you're going to write down. Take some notes here. The plan today is to introduce you to some topics from chapter 14. I'm hoping that as a class this looks familiar because I had you guys do this if you were here a week ago in class looking at chapter 14. We talked about it with our Random Babies activity last Thursday if you were here for that. So today is to get into the actual what I want you to know, how we're going to do some problems with this material, and then tomorrow in the last 15 minutes of class we're going to take a quiz. Okay, 15 minutes, so short quiz, very short quiz. So we're going to practice and work hard the next 2 days. All right, so let's first off talk about ultimately getting to using the word probability. And you may not have noticed this, you might have, but you may not have noticed that I actively avoided using the word probability for as long as I could. Okay, because when I say the word probability, some students have preconceived ideas about what that means. So I actively tried to avoid that word when I could. All right, so there's some words here that you have seen before and some that you haven't. I'm going to focus on actually the last one first, okay, that word sample space. So when we look at probabilities, we're going to have lots of different opportunities for something to occur, and all the different things that could occur is called a sample space. So let's think about something that is in the forefront of your mind right now. We are only 2 weeks away from your first midterm. But your last winter midterms as a high school student. So that's exciting. What? Okay. So if we're 2 weeks away, that means your grades are close to being done. Okay. So right now, think about your grade in a class. Any class, think about your grade. Is everybody thinking about a class and their grade in that class? Doesn't need to be here. It can be any. You don't have. What's up? Jacob's phone? Hey, Jacob, your phone. I know, man. He saw you roaming. All right, let's go to class. Okay. What was I saying? Your grade in a class. Okay. So we have 2 weeks left. Not really. We actually have a week and a half. All right. But we have, is it 8 days? 8 this day and then 7 more. Okay. So 8 days left to get your grades to improve. Okay. So right now, if you have a B, the likelihood you still have a B at the end of these 8 days is probably fairly likely, because it's only 8 days left. So what if you have a B and you want an A? What's your likelihood of having an A at the end of these 8 days? If you got an 88, maybe you got a better chance. But if you got an 82, what's your likelihood of having an A at the end of the 8 days? Not very high. What's your likelihood of having a C if you've got an 88? Hopefully not likely either. Right? Hopefully you're not going to drop all the way to a C if you've got an 88 right now. Okay? You see what I'm getting at? So all of these grades, right now, at this moment in time, you have a probability to get a grade. Okay? So all of those probabilities together is called the sample space. Okay? Everybody good? Okay, we'll talk more about that later. Just want to show you that that's how I view grades. They're constantly changing. Hopefully you view that those grades the same way. They're constantly changing. Okay? All right, let's keep going. All right. Now, I mentioned this law during our Random Babies activity. Okay? So the law of large numbers says that over the long run, the probability of an event occurring will approach its true probability. So we've done this a lot, even without you thinking about it. Go back to your coin flips. If I flip 5 heads in a row, does that mean I'm due for a tails to show up? I'm not due for tails. But after 1 million flips, I will approach my 50-50 split. Okay? So this brings me to something that I want to write down, but it's going to hurt me. It's kind of like when you see in the Harry Potter movies when they have to write down the word Voldemort, and it like pains them to do it. This is going to pain me to do this, but I'm going to write it down. I'm not going to write Voldemort. You're going to see this. If you say that in my presence, and you like actually believe it's a thing, it will mean I have failed you as a teacher. I wrote that down because the law of averages is not real. It's made up. I hear it constantly when I watch TV. Constantly, especially sports. Okay? For example, right? Say I'm watching a basketball game. And in the first half, one of the teams is not playing particularly well. They're missing a lot of their shots. And at halftime, the announcer will say, don't worry, the law of averages says that they'll start making them in the second half. That's not true and not a thing. What that announcer is misunderstanding is the law of large numbers. That over the life, and by life we'll say season, over the season, that shooter or the team will approach its true field goal shooting percentage. So there will be games where they shoot much better than what they're expected to shoot, and they'll shoot much worse. Okay? But in a game, that's a very small sample. So they're misunderstanding this law of averages, which is not a thing. I want you to know that when somebody says that in your presence, wow, that is not what I was going to say at all. Jeez. I was going to say you could take the high road and say nothing, which is what I usually do when I'm in meetings with people at the school. Or you could teach them some knowledge.
Mr. Bradley said this is good.
All right. Let's move into a formula and then eventually into the rules and requirements for probability. And many of these you probably have already learned in middle school or early high school, so you just need a refresher. Okay? So the example my brain always goes to with probability in middle school, or maybe even, late elementary school, is actually, I was going to say, a bag of marbles. And that's what every student, at least for me, that's what every adult remembers. If you've got 3 red, 4 blue, 2 orange, 1 yellow, if I pick one marble out, what's the likelihood that it's a color? That is like pretty much your simplest way of talking about probability. So it looks really complicated there, but that's what the probability of event A means. Okay? How many possible outcomes could you have, and how many are the ones that you care about? So if you have 11 marbles, and you want to know what's the probability that you get a red one, and you have 4 in there, then it's 4 out of 11 is your probability. Okay? All right, so let's move to the rules. This one here says that your probabilities have to be between 0 and 1. So if you say the probability of getting a red marble is 1.2, then that's wrong. You made a mistake somehow. Okay? So it needs to be between 0 and 1, like 0.05 or 0.41. Anything between 0 and 1. Now we'll talk about how we're going to use percentages, because those are not percentages, right? Those are just decimals. What I tell students is I only use percentages when I write a sentence. If I'm doing work or I'm doing math, I'm using decimals. Okay? When you want to write the answer, like the probability of getting a red marble is 4%. That's when you would write it. But during our work, we don't use percentages. Pretty good there? Okay. That's just a statistical way that we write. Now, right here at the very bottom, all of your possible probabilities should add up to 1. So if you're looking at the probability for all your events happening and they don't add up to 1 or 100%, something else is wrong. Okay? Either you're missing one or somebody wrote something down wrong. Something is up. Okay? So it's always a quick check. And some of the problems you'll see on the tests, and the quizzes and things that you take in this class and in other stats classes, they'll give you like 4 out of 5 of the probabilities, and they'll say the rest is for this event. So you have to subtract from 1. Okay, we'll do an example of that today. Awesome. All right, let's keep going. Almost there. Now, the complement rule just means that if I tell you the probability of something happening is a number, then the probability of that not happening is 1 minus that probability. Okay? So if your probability of getting a B in this class is 0.7, your probability of not getting a B is 0.3. 1 minus 0.7. That's called the complement. So whenever somebody says, hey, you guys really complement each other, I say, yeah, I know. I'm 1 minus my wife. No? Good stat show? Bad stat show? No? Yeah. Those kill at the adult parties. Kill. They don't. Usually people look at me funny. And I say, you know what? I didn't want to be friends anyway. Okay. The addition rule. The addition rule is when you want to find out what's the probability of you getting an A or a B in this class, then you're going to add them together. Now, there's a rule that allows us to do that, though. And it has to do with grades. And getting a grade in a class, those are called disjoint events. If I tell you that you're getting a B in this class and the grades are over, you got a B for semester 1. What's your likelihood of getting an A? For semester 1. If I told you you got a B for semester 1, what's your likelihood of getting an A for semester 1? 0. It can't happen. They're called disjoint events. Okay? So if something happens and then the other thing you're looking at can't happen, then those two things are disjoint. Another word we use is mutually exclusive. Right there. Disjoint or mutually exclusive. They mean the same thing. Disjoint or mutually exclusive. So we're always going to make that check before we use the addition rule to do the probability of A or B. So this right down here, this formula, we're always going to ask ourselves, do we think that those two events are disjoint? If we say yes, great. Then to find out if one or the other happens, we'll just add their probabilities. Yes? Oh, great question. So it means union and it means or. The C is complement. That little baby C is a complement. So if you ever see that C as like a power, that's telling you it's the complement of whatever that probability is. I guess what would make more sense is probably this. Yesenia? That's probably more how we'll do it. If I tell you the probability of getting red is 0.3, then 1 minus 0.3 is the probability of getting not red. Don't worry, we'll do problems. All right, let's do one more slide. All right, now the multiplication rule. This says that if you want to find out the probability of an event happening and another event happening, so 2 events happening, then we multiply the probabilities. But we assume something. We assume that they're independent. Now, independence is this is how I view independence with events. If I tell you that something has already happened, okay, I tell you something's already happened, then the probability of that other thing happening should not have changed. All right? So what's the probability that you show up to school on time? 50%. Wow, that is real sad. What's the probability? Look, should we just say not you? Let's just say the senior class. What's the probability the senior class gets to school on time?
80%.
Wow, that's real sad. 80%? That's much nicer. Okay, well, 75. So let's go with 75. Okay, now, does everyone have that in their brain? Okay, 75% chance that all the seniors arrive at school on time. Now I tell you, okay, I tell you that Saudi Arabia has bombed Yemen. Okay? What's the likelihood that the seniors get to class on time that day? Do you think it's changed? So I would argue it hasn't changed. Okay? So that means those events are independent events. Now, let's try another one. Ready? You told me it's 75%, right? What if I tell you at 7 a.m. there was a massive blizzard and the roads are icy? Now, what's the probability of you guys getting here on time? You think it's still 75%? No, I bet it goes down. If the road conditions are not great, I bet it goes down. All right, so those would be not independent. So if it changes that original probability, then they're not independent. Okay, so we're going to check that as well. Do we think they're independent? Now, here's the kind of the nice thing about being in stats. You can actually break this rule. Okay? Think of it like this. I'm going to show you an example of when you can break this rule. All right? One of the most magical places that I want to go that I've never yet been to is the Mars M&M factory. Have I? So, I want to go to wherever this place is because in my mind it's just vats of M&Ms where I can just take swims and just eat some. All right, it'll be great. Okay? I imagine they have a vat of orange, blue, green, yellow, all the colors. Okay? Just massive, like millions of them in one place. So if there's a million yellow ones, a million green ones, a million of all the colors, and I take one out, have the probabilities changed? Yes. Yes. How much do you think they've changed? Probably where you can't even see it, but they've changed. So even though I've broken the rule of independence, the probabilities have changed, we still can use this because the change is so small. Okay? We'll talk more about that as we go, especially second semester, like early second semester, first few weeks. Okay? But I just want to tell you that the rule can be broken. Okay? All right. Shall we try some examples? All right, let's do this thing.